Hi, I am Dr. Saroja. Today I am going to give a small little introduction to gaseous state. There are three different states of matter in nature, that is solids, liquids and gases. Now let us see the properties of these three phases. Let's compare the properties. The first property is density. Solids have very high density, liquids have intermediate density and gases have low density. Let's see particle packing. In solids, the particles are tightly packed, and in liquids, there is more movement, and in gases, the particles are all spread out. Particle arrangement. In solids, the particles are regularly arranged in geometric shapes, and in liquids, there is no arrangement, and in gases, there is no arrangement. Shape and volume. Solids have very definite shape and volume, whereas liquids occupy the volume of the container and the shape of the container. In gases, there is no shape and they have the volume of the cylinder in which they are kept. Compressibility. Solids are least compressible because there is very little free space among particles, and liquids are slightly compressible and gases are very highly compressible because there is a lot of space between the molecules. Bonding. Solids have very strong bonds like ionic bonds, and liquids have weak bonds like covalent bonds, and the gases have weak van der Waals forces between the molecules. Movement of particles. The solids are rigid, the particles don't move, they only vibrate over short distances. In liquids, the particles move past one another, they slide over one another, and in gases, the particles move freely over large spaces. And the examples of solids, liquids and gases we find plenty in nature, and the most common salt is the example of a solid, and liquids, the most abundant liquid is water in nature, and gases, air is a mixture of gases, oxygen, nitrogen, carbon dioxide are all examples of gases. This is one exhaust gas that's coming out of the pipe of an industry. Let's see the properties of gases. And also let's see what is change of state. There are three most important properties for gases. Pressure is P, volume is V, and temperature, small t is degrees centigrade or degrees Fahrenheit, and capital T is the absolute temperature. What are the units? SI units, system international units. Pressure is force per unit area, so the unit of pressure is Pascal, PA, that is equal to 1 Newton per meter square in SI units, and the pressure is 1 atmospheric pressure at sea level, and that 1 atmosphere is equal to 101,300 pascals. Volume 10 into 10 into 10 centimeters becomes 1000 cc's, and that is equal to 1 liter. Centimeter cubed is written abbreviated as 1 cc, and that is approximately equal to 1 ml. Temperature is either in centigrade or Fahrenheit, and that is written as small t, and Kelvin temperature is the absolute temperature, that is written by capital K. 0 degrees K is equal to minus 273 degrees centigrade. Let us see what is change of state. When temperature is increased, solid changes to liquid and liquid becomes gas. When pressure is increased, gas becomes liquid, gas gets compressed, and liquid gets compressed to solid. What is STP? Standard temperature and pressure. ST, standard temperature, is 0 degrees centigrade, that is equal to 273 degrees Kelvin, and standard pressure is 1 atmospheric pressure. This is called STP. The most famous theory of gases is kinetic molecular theory. This is a model for the behavior of gases. There are some postulates in this theory. The first postulate is molecules are so small that their volume is negligible compared to the space between them. Volume of the molecules is negligible compared to the total volume of the gas. Second postulate, the molecules are in constant motion in straight lines with constant speed, moving in random directions before the collisions. Once the collision occurs, the direction changes. Collisions of molecules on the walls of the vessel it creates pressure, force per unit area, and the collisions are on the walls of the vessel, they create this force. Collisions are elastic. Kinetic energy is the same before and after the collision. And the third postulate is the molecules experience no intermolecular forces as the collisions are elastic. There are no intermolecular forces between molecules, but this is not true for real gases. The last postulate is average kinetic energy of molecules is directly proportional to temperature. Ke average is directly proportional to capital T, that is Kelvin temperature. A gas that fulfills all these postulates is called an ideal gas. Most real gases, they are ideal, more or less ideal under ordinary conditions of temperature and pressure, that is room temperature and room pressure. There is one famous equation for gases, that is ideal gas equation. P, V and T of a gas are related by an ideal gas equation. PV is equal to nRT is the ideal gas equation. P is the pressure, V is the volume and N is the number of moles and R is the universal gas constant and its value is 0.0821 liter atmospheres per degree Kelvin per mole, and in joules it is 8.3145 joules per Kelvin per mole. T is the absolute or Kelvin temperature. Under ordinary conditions, real gases behave like ideal gases, we have seen. What is the application of this ideal gas law? There are two applications. The first one is out of PV and RT, if four variables are known, the last one can be found out, missing one can be found out. The second application is for two different conditions of a gas. First condition is 1, second condition is 2. If we rearrange this equation, PV by, if we bring T here, PV by T is equal to NR. N and R, if we keep N constant, R is also a constant, so it becomes PV by T. For the first condition, it is P1 V1 by T1. For the second condition, it is P2 V2 by T2. These two are equal because the gas is the same. And if we know out of all this, if we know all variables except one, the missing variable can be found out. Let's see how we can apply these two for the ideal gas equation. The first case, one example, 2 moles of hydrogen gas at 27 degrees centigrade fills a 5 liter balloon. What is its pressure? PV is equal to nRT is the equation. 2 moles is N. 27 degrees centigrade is the centigrade temperature and it should be converted to absolute temperature. 27 degrees centigrade plus 273 becomes 300 Kelvin. And 5 liters is the volume, 5 liters, and if we substitute all the variables, P can be found out. P is equal to N is 2, R is 0.0821 liter atmospheres per Kelvin per mole because we are dealing with pressure and volume, therefore this value should be used. And R is substituted, then T is 300 Kelvin and liters, 5 liters is the volume. If we calculate this equation, we get P is equal to approximately 10 atmospheres. This is a rounded up value. So like this, the missing parameter can be found out using this equation. The second application, for two different conditions of a gas, we can find out the missing parameter. One example is helium at 2 atmospheres fills a 100 ml vial at 0 degrees centigrade. This is the first condition. What would be the pressure if the volume increases to 200 ml and 10 degrees centigrade? This is the second condition. P1 V1 by T1, P2 V2 by T2, and P2 we can find out. If we take T2 here, it goes into the numerator, V2 comes down in the denominator. So P2 is equal to P1 V1 by T1 into T2 by V2. Now let us substitute. P1. P1 is equal to 2 atmospheres and V1. V1 is 100 ml converted to liters, it will be 100 by 1000. That will be 0.1 liters. And T1, 0 degrees centigrade converted to absolute temperature, it becomes 0 plus 273, it is 273 Kelvin. And T2, 10 degrees centigrade is the second temperature, plus 273, it becomes 283. So T2 is 283. And V2, V2 is 200 ml divided by 1000, it becomes 0.2 liters. So if you substitute all the variables, the unknown variable P2 works out to 1 atmosphere. This is a rounded figure, and like this we can calculate the missing variable for two different applications. So this is a very small introduction to gaseous state. There are other laws Those can be taken up in the next video. And if you like my presentation, please subscribe to it. And thank you for a patient hearing. Thank you so much.